All right, these are the examples for Geometry A, Credit 1, Lesson 1.1. All right, so starting off, we're going to be going over some definitions, and let's take a look at the definitions that we have over here. So the first thing we have is a segment, or sometimes we call this a line segment. So a line segment has a starting point and an ending point. So there's a definite start, a definite end. We call that a line segment, and we represent that with the two endpoints with a little segment symbol on top. So that's line segment XY. A line is similar to a line segment, but however, the line goes on forever in both directions, and that's indicated by the arrows. And so a line, we would still pick 2 points on the line, but instead of the segment symbol, we're going to have the line symbol on top. So that's line XY. Finally, we have array. Array is kind of a combination of a segment and a line in that there is an endpoint, but it, it goes on forever in one direction. So it starts at one point and then goes on forever in the other direction. And so we always name array starting with the endpoint and also with another point, in this case y, that's on the line. And then we put the little ray symbol above it, and that's ray XY. One important thing to note about rays is that for array, you have to name it starting with the endpoint. You can, for example, if we were to call this ray YX, that doesn't work, or that would not be appropriate for this because X is the endpoint, and so that we could not do. So those are the examples for one. Actually, that's 1, 2, and 3. So let's make a note of that. So now, for example, for problem number 4, coming over here, we have 4 things we're going to go over here. First of all is segment addition postulate. And so if we have a line segment, the big line segment here, RT, if we break that up into 2 smaller segments, those smaller segments, RS and ST, if we add them together, their length, if we add their lengths together, that's equal to the length of the entire segment. So that's the segment addition postulate. Definition of a midpoint. Definition of a midpoint is going to look similar to the segment addition postulate. However, the point that's in the middle of the segment divides the bigger segment into 2 equal pieces. And we can indicate that with the tick marks here. So we can say RS equals ST. RS equals ST. Next item that we're going to go, or definition we're going to go over, is the addition property of equality. And what that is this: if we have some statement A equals B, if we add the same thing, we're going to call that C to both sides. The 2 sides of the equal sign remain equal. So for example, if we had like 5 equals 5 and we add 2 to both sides, that's still equal. 5 plus 2 is 7. 5 plus 2 is 7. That's the addition property of equality. Finally, definition of a angle bisector, last one for number 4. So if we have the bigger angle here, let's show that first, RST, and we draw a bisector in here, we're going to call that bisector ray SU. And a bisector, what that does is divides the larger angle into 2 smaller angles that are equal to one another. So whenever we're dealing with a bisector, we're dividing the angle into 2 equal angles. All right, so that's our examples for 1, 2, and 3, and number 4. For 5 and 6, that is identifying the formulas for the midpoint and the distance formula. For those, you can Google those, or maybe you know those already, but you might want to double check by Googling. So that's what you can do for 5 and 6. Just simply Google midpoint formula or distance formula, and that should pop up. I just checked it. It'll pop up as the first result. Going on to, so that was page 21, problems 1 through 6, the examples, and then for 5 and 6, how to obtain the example. So now once you have those formulas for midpoint and for distance, on the next page, you're going to be asked to work with those formulas. And I guess we're going to see the formulas here, so that'll kind of give away what they are. But maybe you've Googled that already. Maybe you stopped the video and did that. So let's take a look at an example for, so we have 7, 8, 9, and 10 on the back. So this is the midpoint formula, and that's problems 7 and 8. So this example will help you with problems 7 and 8. So we have the points 3 and -2, and -8 and -12. And what we want to do is find the midpoint between these 2 points. Now we're not going to graph that, although you could graph it to kind of confirm your answer. But just to explain what we're doing here, if we were to graph this, and just say, for example, the line segment would look like this. Finding the midpoint, again, tells us that point that's exactly in the middle between the 2 endpoints. So just a reminder of what that is. So our midpoint formula, here it is. And we'll put it up here, x sub 1 plus x sub 2. And then over here, y sub 1 plus y sub 2, and we're dividing both of those by 2. So basically what you're doing is you're averaging the x coordinates and you're averaging the y coordinates. And so you might wonder, well, are we always dividing by 2? And yes, we're always dividing by 2 because we're always, whenever you're doing an average, you add the numbers up and then you divide by how many numbers you added up. So since we're always adding up 2 numbers when we're doing the midpoint, that's why we're always dividing by 2. So let's go ahead and label, make sure we can see this okay. Let's go ahead and label our points. This is our first ordered pair, so this will be our x sub 1, y sub 1. And this is our second ordered pair. This will be our x sub 2, y sub 2. And so now we're just careful to substitute those values in the appropriate place. So x sub 1 is 3. X sub 2 is -8. And then we're dividing by 2. And then over here, y sub 1 is -2 plus y sub 2, which is -12. And then we're also dividing that by 2. All right, so let's go ahead and work that out. So 3 plus -8. So we're adding numbers with a positive and a negative. So when we do that, we subtract the numbers. 8 minus 3 is 5. And since the larger number is negative, that's going to be a -5. So -5 over 2. Over here, the signs of the 2 numbers are the same. So we're going to add the numbers up. 2 plus 12 is 14. And whenever the signs are the same, the answer keeps the same sign when we're combining numbers. All right, so now we have this. Now, -5 over 2, that is a simplified fraction. So we could leave it like that. But we can also convert it to a decimal. And the way we do that, since a fraction bar means divide, -5 divided by 2, if we pull out the calculator and do that, or maybe we can even do that with mental math, that would give us -2.5. -14 over 2, 2 is definitely divides into 14 because 14 is an even number. 2 will divide evenly into any even number. So 14 divided by 2 is 7. And then a negative divided by a positive is a negative. So our midpoint here is at -2.5 and -7. So that is the example for problems 7 and 8. And again, we go through these pretty much at full speed. But if you need to pause the video to make sure you understand everything or rewatch the video to have a better understanding, please do. And you can even slow down the playback speed on YouTube. You can even slow that down and watch it like that. All right, so now our next and I believe final example is for the midpoint formula. And let's take a look at that. So this is the example for problems 9 and 10. Or excuse me, I think, did I say midpoint? If I did, I meant distance formula. So to clarify, this is our example for the distance formula, problems 9 and 10. All right, so our ordered pairs here are going to be 5 and -9, and 12 and 15. And let's go ahead and write the formula up here. And so we have x sub 2 minus x sub 1. And we're going to square that, and then plus y sub 2 minus y sub 1 squared. All right, so now let's go ahead and label our points. This is our first ordered pair, so this is our x sub 1, y sub 1. And this is our second ordered pair, so this is our x sub 2, y sub 2. So substituting, carefully substituting in the appropriate spot for everything, we have x sub 2 is 12 minus x sub 1, which is 5. And don't forget it's squared. And then y sub 2 is 15 minus y sub 1, which is negative 9. So careful, we have two negatives there. A negative or a minus from the formula, and then also a minus because y sub 1 was a negative. And of course, that's squared as well. All right, so now order of operations says that we do our grouping symbols, our parentheses first. So 12 minus 5 is 7, so 7 squared. We haven't done the exponent yet, so it's still squared. And then now 15 minus a negative 9. Whenever you're subtracting a negative, that is, in effect, addition. So that's 15 plus 9, which is 24. And so we have 24 squared. And another explanation for that, remember, we can change the signs. We change this to an addition by changing the sign of the second number, and we can see that it is addition. So, or just remember that subtracting a negative does mean addition. All right, so now it's time to do the exponents. We have 7 squared, which of course means 7 times 7, which is 49. And then 24 squared, which means 24 times 24, which is 576. Next, we're going to add these up. 649 plus 576 is 625. And now we need to take the square root of 625, and that is 25. So you just use the square root symbol on either Desmos or on your calculator, and that the square root of 625 is 25 because 25 times 25 is 625. All right, so that's it for the examples for lesson 1.1. Again, pause, rewind the video as needed, and good luck with your work. Take care and God bless. Bye-bye.